Algebra 2 Honors 4.9 and 5.1. We're just going to pick up one type of problem in 4.9 and then move on to 5.1. And in 4.9, it's about modeling polynomial functions. And the type of problem we're going to do is we're going to be given a graph and some specific points, and you're going to write the equation in factored form for this polynomial. And so in 4.9, this first example, what you're going to notice is what are the x-intercepts. And they are at -3, at 1, and at 2. And then that means that the factors are x plus 3, x minus 1, and x minus 2. And so we know that if I multiply those out, I'm going to have a polynomial that goes through those 3 x-intercepts. But we also need to consider that there could be a vertical stretch, and maybe even a reflection in the x-axis. And so what we're going to do is use a point that is not one of the intercepts. So I see 4 points, 3 of them are intercepts. So the point that is not an intercept is at 0, 3. And we're going to set up this polynomial. We need it to be a function, so we need f of x equals. And we're going to have an a, which is going to be a value. If it's negative, there's a reflection in the x-axis. Otherwise, if it's something other than 1, there's also a vertical stretch. So a times x plus 3, x minus 1, and x minus 2 that we're getting by looking at those x-intercepts. And so now what we do is we are going to plug in that other point that was not one of the x-intercepts for y and for x and solve for a. So y will be 3 when x is 0. And solve for a. And so we're getting 3 is equal to 6a. Divide by 6, be careful, it'll be 3 over 6, which reduces to 1/2. And then write the final function, which needs to have f of x equals, and then leave a as the exact fraction, don't use a decimal, and just write it out in front and leave the polynomial in factored form. Do not multiply it out. And then box that, that is your final answer. So you'll have a couple of problems from 4.9 just like that. Then moving on to 5.1, we're getting into the nth root and rational exponents. And so the nth root, if we read through this first paragraph, you can extend the concept of a square root to other types of roots. For example, 2 is the cubed root of a because 2 to the third is 8. And so we're going to be having that the cubed root of 8 is 2. So that's that nth root of 8. The third root of 8 is 2. So in general, for an integer n greater than 1, if b to the n is a, then b is the nth root of a. So 2 is the third root of a. The cubed root is what we say. All right, and so an nth root is written like this, where n is called the index of the radical. So in this case, 3 is the index of the radical. So some things to understand in the core concepts. When n is even and a is greater than 0, there are 2 real roots. And the positive root is called the principal root. And so if a is less than 0, there are no real nth roots. If a is 0, there's one nth root, which is 0 itself. And when a is positive, there are 2 real nth roots, but the positive one is called the principal root. So when we see the cubed root here, just as another note, of the -64, I know a -4 cubed is 64. And so that is the cube root of a -64. So It doesn't defy what we said before, because this said if n is an even integer. This is not an even integer, this is odd. And the cube root of a negative number is another negative number, so it is doable. It exists. However, notice in the second case, we have an even index. And just as is stated up here, when a is less than 0, there are no real nth roots. And so right here, I can't take the fourth root of a negative number under the reals. There is no real answer. So when the number under the radical sign called the radicand is negative, if it's an odd root, we can take it. If it's an even root, we will have no real answer. And we're just looking for real solutions at this point. So 5.1, example 1, find the indicated nth roots of A. So right here, this means we have the fifth root of a negative 243. And that's one of those that you want to recognize. That if you take 3 into 243, you get 81, and 3 goes into their 27, 3 goes into their 9, and that's 3 times 3. So 3 to the fifth is 243. And since this is a negative 243, the fifth root of a negative 243 is a negative 3. And we can also write this. The quantity negative 243 to the 1/5, that means the same. And the answer to that is negative 3. You want to try to do these without calculator. On the sections, especially that says no calculator, do not pick up a calculator to do these. Use prime factorization to help you figure out how to evaluate these. So now, when they ask for the nth root of 256, well, for 256, I know that is 16 squared. It's 16 times 16, which is 2 to the 4th times 2 to the 4th. Or in other words, 256 is 2 to the 8th. I could have also done the prime factorization. 2 goes into there, 128, 2 goes into there, 64, 2 goes into there, 32, 2 goes into there, 16, 2 goes in there 8 times, and 2 goes into there 4, and then 2 times 2. I kind of got in a rush there. And if you count those up, that's 2 to the 8th. So 2 to the 8th is 256. So when I have the 8th root of 256, and this is going to be, because it's saying find the indicated nth roots of A, this is even, we are going to say that the answers are plus or minus 2, because this is how the directions are originally asked. And we'll talk about that in a little bit here. And so anyway, so now down below, rational exponents. Let a to the 1 over n be the nth root of a, and let m be a positive integer. And they're just showing you some relationships. A to the m divided by n can be a to the 1 over n to the nth power. Or you can think of it as the denominator is that index on the radical. That is your nth root of a raised to the m. If that fraction, that exponent's negative, you can drop it to the denominator and it will change in sign. And then we can apply the same two properties that were originally shown, as long as a is not 0, so you are not dividing by 0. So in example 2, it says no calculator. Don't use one. You need to be able to evaluate this without. And so when we have the 64 to the 4/3, I can think of this as 64 to the 1/3 to the 4th. That's applying this property right here. And 64th to the 1/3 is the cubed root of 64, and 4 cubed is 64, so this means I have 4 to the 4th. And if I multiply that out, I am getting 256. Be sure on your homework to write the original problem down, not just the answers. However, if I want to use this other format, I can change 64 to the 4/3, and I can think of it as the denominator is the index on the radical to the 4th power, which once again, the cubed root of 64 is 4, raised to the 4th is 256. So there's a couple of ways that you can think about that, and you should be flexible and be able to think of both of those. Now, if you have 16 to the negative 5/4, the first thing you should do, or suggestion, is to drop it to the denominator, and then you change the sign on the exponent to be positive. And then I can use either method to rewrite this. I can think of this as 16 to the 1/4 raised to the 5th, or I can write it as the 4th root of 16 quantity to the 5th. And since 2 to the 4th is 16, the 4th root of 16 is 2. So I get 1 over 2 to the 5th, which is 1 over 32. And that's how you should leave your answer. Now, if the section says use a calculator where necessary, you should try to do the problem without first. If you use a calculator and you have an integer answer, you should go back and do it without a calculator. So in this one, we have 7 to the 1/4. And so I'm thinking, okay, that's the 4th root of 7. That's not anything to the 4th. 1 to the 4th is 1. 2 to the 4th is 16. So it's got to be somewhere in between 1 and 2. So go to your calculator. And you can go to Desmos or use your scientific calculator. And we have 7 and raised to the 1. Oops. There. And enter. And then to 2 decimal places, 1.63. Again, copy the original problem down so I know that 7 to the 1/4 is approximately 1.63. 10 to the 2/5, I'm thinking, okay, the 5th root of 10 squared. Well, this is not any known integer value, so this is a calculator problem. So go to Desmos, and we have 10 to the 2/5, and there we have 2.51. And on this next one, I just need to remember this is the same as 11 to the 2/3. The index goes as the denominator. And the cubed root of 11 is not any number that I know. I know 2 cubed is 8. 3 cubed is 27. So this is some number between 2 and 3, and then you're going to square it. So it's a calculator problem. So go to 11 and 2/3. And there we have 4.95. 4.95. So approximately equal to, and make sure you copy down the original problem. The original problem. All right, and then example 4. You're going to be solving equations, and as you solve these, you need to isolate the base that is raised to the nth power. And then you will take the nth root of both sides. Only use a calculator if the answer is not an integer or rational number. So I'm going to try and first do these without a calculator. And so when I say isolate that base, I want x to the fifth isolated. So the first thing you need to do is divide both sides by 4. Again, write the original problem down. And 4 goes into 128 32 times. And then we are going to take the nth root of both sides. So there's a couple ways you can show that. You can raise them both to the 1/5. That's going to take it to the nth power. And when we have x to the 5th to the 1/5, that is just x. And the 5th root of 32 is 2. Okay, or I could have, once I got to the x to the 5th equals 32, I could have shown taking the 5th root like this and still getting the same answer. All right, on this next one, you have x minus 3 to the 4th equals 21. And so in this case, the x minus 4, or the x minus 3, excuse me, is the base. And so it's already isolated. And so if you started with something like, if it started like this, you would need to first divide by 2 to isolate that base of x minus 3 to the 4th. So if it started like that, you would need to do that first to isolate that base. But in this case, it is isolated. So I'm going to go ahead and find the 4th root. Since it's to the 4th, that base is to the 4th, I'm going to take the 4th root. So that means raising it to the 1/4 on both sides. But when I'm taking an even root, you need plus or minus on that. You don't need it with an odd root, because over in example 8, if I take 2 to the 5th, I get 32. If I take a negative 2 to the 5th, I do not get a positive 32, I get a negative 32. So the only correct answer on part A is positive 2. However, when we're taking an even root, I'm going to need both positive and negative when I'm solving an equation, So here in part B, when I take the 4th root on the left side, I'm just going to be left with x minus 3. And on the right, I am going to have plus or minus, and maybe I want to write it as the 4th root of 21. Add the 3 over. And that is my exact answer. 3 plus or minus, there's 2 answers. There's both the plus and the minus. So if they ask you to round it to 2 decimals, then you're going to need to put this into your calculator and evaluate. And so you can go to Desmos and do that, or use your scientific calculator, check out that you are able to do that. And it comes out to 5.14 or 0.86 to 2 decimal places. Okay. Now I want to go back to this other thing about even roots. If the directions say simplify the 4th root of 16, your answer is only 2. We only want the principal square root, which if you recall on the first page, that is just the positive result. And so if they ask you to just to simplify that, you just put positive 2. However, if they ask you to solve x to the fourth equals 16, you are going to take the fourth root of both sides, and that's an even root. You are going to need to put plus or minus, and your answer x is plus or minus 2. So solving and taking an even root of both sides, you're going to need plus or minus. However, they just ask you to simplify that even root, it's just going to take the principal root. The exception to this is in the section where they say, find the indicated nth roots. When it is an even root, they are going to want it to be plus or minus. So if those are the directions, then on the even root, put plus or minus. But if the directions are just simplify, then just the principal root. However, over here where you're solving, if you end up taking an even root of both sides, don't forget the plus or minus. So those are just some little details that you're going to have to memorize. That's it.